So we're all here, it looks like. So the first thing we'll do today is go over that chapter 14 problem set. So let me get it open here. Let's see. There we go. So what are we being asked to do here? We're being asked to calculate in this first part, given this production function, or total product function, we're being asked to calculate the average and the marginal product at each level of output. All right, so here's what I'm going to do. I'll add 2 new columns to this table just to fill in the results. It'll just be easier that way. We'll put in 2 columns. Okay, this should do it. So the average product will go here, the marginal product will go here. Okay, so in the first row, there's no definition here. You cannot have an average or marginal product when there's no output. Okay, but after that, it's pretty straightforward. Here's what you're doing. The average product, I might as well add this to the top here, equals TP over L. Okay, so that's exactly what we're trying to do here. We're going through all of the levels of output. For example, 10 espressos are produced by 1 worker. So that's just 10. Okay, hold on, let me see if I can make this a little bigger. So then the next one is 25 over 2, which is just 12.5. The third one is 37 over 3, which is 12.33. And of course, as you can see, in each case, all we're doing is we're taking the total product and dividing by the output, or it's not the output, sorry, the quantity of labor. Okay, the next one is 46 over 4, which is 11.50. And then finally, this last one is 53 over 5, which is 10.60. So those are the easy ones, all right? So again, you're just taking this number and dividing it by this number in each case. Total product divided by average product. The marginal product one is the tricky one because what you've actually got is not TP over TL, but you're looking at the changes in those 2 quantities. So hold on one second. I need some symbols here. There we go. So I need the change in total product over the change in labor used. Okay, so for example, in this first case, when you go from 0 to 1, output jumps up by 10. Oops. So I'll put that as 10 minus 0 divided by 1 minus 0 because we increased our output by 1. So this is actually 10 over 1, which is just 10. Okay. So in other words, if what you're seeing here is that 10 minus 0 means the difference between the 2 levels of espressos divided by the change in labor. So for the next one then, based on that logic, we'll have 25 minus 10. In other words, the espresso went up by 15 when we increased our labor from 1 to 2. So that ratio works out to be 15 over 1, which is just 15. So you can see initially it is going up as we expected. And then pretty soon it should start falling. Possibly as soon as the next level of output, we have 37 minus 25 over 3 minus 2, which is 12 over 1, which is just 12. Okay, so already it has started to decrease. Okay, so it went up at first, but now it's already turning down. And as you know from the chapter, once it starts turning down, it'll continue to fall forever. All right, then we have 46 minus 37 over 4 minus 3, which is 9 over 1, which is 9. And then finally, in the last case, we have 53 minus 46 divided by 5 minus 4, which is 7 over 1, which is just 7. All right, now it doesn't actually ask you to graph these, but you kind of get the idea. The average product at first rises and then it falls off. The marginal product does the same thing. If you were asked to draw it, let's just give it a rough sketch. You'd have total product here, and here's labor. Now, average product would rise at first and then start to fall, and then marginal would do something like this. Okay, and the key to the whole thing is that they cross, the intersection occurs when average product reaches its maximum value. Okay, and they both have the same basic shape. They rise and then fall, but you notice how the marginal product curve rises more quickly and then it falls off more quickly. And in addition, in fact, let me change this a little. This one can actually become negative. So let me show that here. The marginal product can literally become negative. So let me just indicate that here. Not so the average product. That can't ever be negative because the total product can't be negative, but the marginal can be negative. So we certainly don't want to keep producing where the marginal product is negative, but it is possible. Now here we have Starbucks. Oh, it's the same thing, except now we have more efficient machines. All right. So we're going to do the same thing. What's different this time is that because we have more efficient machines, let's say espresso machines are faster, we can churn out more espressos per day than we could before, even with the same amount of labor. So we're going to redo all these calculations, except, oops, not that. This time with more efficiency. All right, let's see. Let me get this straightened out. All right, so let's do that again. I'll steal these labels. Okay, so let's do this one again. Now here, of course, average equals total over L. So this one will be 15 over 1. And then here we'll have 31 over 2. 15.5. Here we have 48 over 3, which is 16. 64 over 4, which is also 16. And then 76 over 5, which is 15.2. The marginal products, everything's the same. Here we have 15 minus 0 divided by 1 minus 0, which gives us 15. When we go to the second worker, output goes from 15 to 31, as output, the number of workers goes from 1 to 2. And so that's 16 over 1, which is 16. Oh, I see what I did. Okay. That's better. Okay. Now for this one, we have 48 minus 31 divided by 3 minus 2, which is 17 over 1, which is 17. And now this is where it starts to turn down. 64 minus 48 over 4 minus 3, of course, equals 16 over 1, which is 16. This is, and you can see, yes, it's starting to dip down now. And then finally, we have 76 minus 64 over 5 minus 4, which is 12 over 1, which is 12. All right. Now, a couple of things that we note here. Well, first of all, let me give you a second to catch up here. But what I'd like to do is show you how they compare to each other. In other words, what difference did it make that the espresso machines were more efficient? All right. So I'll give you a minute to catch up with all these calculations. And then what we really want to do is see how they compare with each other. Oops. All right. So what I really want you to see here, well, first of all, let me go get the other table back so we can look at them together. That's the only way to compare them. So hold on one second. Let's see. I've got to make enough space for everything to fit. Let's see. Yeah, I guess you can just about see it. It's a little tight here, but what I really wanted you to notice, though, is that in the average product column up here, the numbers in the new average product column are all higher than in the old average product column. And in addition, the same thing is true of the marginal products. If you look at them side by side, you can see that they're higher now than they were before because of that more efficient machinery that we're using. The calculations haven't changed, but what has really changed more than anything else is if you look at the total product column over here, you can see the numbers are significantly higher. 10 versus 15, for example, 25 versus 31, 37 versus 48. And so you can see the reason why this is happening is because the machines are more efficient. They're just faster. They went out and bought the newest version of the espresso machines, which can make the espressos a lot faster than the old machines. So the workers still just standing there making, doing what they have to do, but the machine is really a lot more efficient. So if you were to draw these curves again, the way you can visualize it is that the average product curves and the marginal product curves have actually shifted up because the total product curve went up as well. So in other words, if you had them side by side, and this is just a rough sketch. I mean, we could do this properly in Excel, I suppose, but let's just draw a rough sketch of what this would have looked like. This would have been the original total product curve. I'll call it TP1. And then the new one would have been shifted up because of the fact that we now have more efficient equipment, and therefore we can produce more output at every level of labor. And the consequences are on the average product. Let's call this AP1 and MP1. Then what would have happened is that with the new total product curve, we would have had something like this. In other words, they're basically the same shape, except that they're shifted up. Okay, and again, it's because of increased productivity due to the increase in the quality of our equipment. Okay, so now we can jump ahead to the next one. I think we understand this. So now if you look at this, oh boy, look at this one. All right, so what I'm going to do is actually put in some formulas for you. First thing first, the cost of the capital here, the capital is the fixed resource. Now, it turns out that each unit of capital costs $20. And we're using 10 units of capital to produce this product. So therefore, it must be the case that we're spending $200 on capital no matter how much output is being produced. Okay, so note, I'll just put a note up here. Total fixed cost equals the total capital used times the cost per unit of capital, which is 10 times 10. No, sorry, 10 times 20, which is $200. Okay, so that's the explanation for where this is coming from. So you literally just copy 200 into each row here. The variable cost is the labor. That would be the total labor used times the cost per unit of labor. Now, for that one, we don't have the ability to produce a constant formula here because the labor changes. So all we can do here is just note that each time we increase our labor, it adds $10 more to our variable costs. Okay, so we could just write this as total labor used times $10, which means here we'll have 0. Okay, and then at the next level, we'll have 10 because each unit of labor costs $10. So in other words, if you can see, this will just keep going up by $10 each time L goes up. Okay, so those are easy. Now TC is easy because you just add together TFC plus TVC. So literally all I have to do now is add these together from the previous two columns. Okay, now this is where it gets tricky. Now the first row of averages and marginals, these are all undefined. So as you know, the average is just total fixed costs over Q. All three averages are done the same way. You take the total, corresponding total, and divide by Q. Except for the last one, ATC could be calculated simply as AFC plus AVC. If you feel that it's easier to do it that way, that's fine. So, all right, let's do it now here for average fixed costs. So this one can get a little tricky. We're looking at this column, and then we're simply dividing by the quantity out over here of output. All right, so for example, this first one would be 200 over 5, which is 40. This one will be 200 over 15, which is 13.33. Yeah, I'll have to fix these columns a little bit. I can see that I'm running out of space. All right, that should do it. Maybe that'll leave, but I need room for the others too. So let's do it like this. All right, so for the next one, it's 200 over 30, which is 6.67. And then I'll have 200 over 50, which is 4. And then 200 over 75, which is 2.67. 200 over 85, which is 2.35. Okay, 200 over 90, which is 2.22. And then finally, we have 200 over 92, which is 2.17. All right, so now these are a little easier than most of them because in each case, the numerator is 200. Okay, but when it comes to the other two, now average variable cost, we're taking total variable cost and dividing by output. All right, so it's a little different now. So for example, in this first case, we have 10 over 5, which is 2. Then we have 20 over 15, which is 1.33. Then we have 30 over 30, which is 1. That's kind of nice. Then we have 40 over 50, which is 0.80. 50 over 75, which is 2/3 or 0.667, or let's call it 67. Then we have 60 over 85, which is approximately equal to 0.71. Then we'll have 70 over 90, which is equal to 0.78. And then finally, we'll have 80 over 92, and that's 0.87. Ooh, that's a lot of calculations. And now, so this is like why I said before, ATC is just the sum of these two. You can do the divisions if you want to, but I think it's easier to just add from left to right. Why not? They're already staring us in the face. Why not just add them together? And we'll come up with 1466, 767, 4.80. So much easier. 324. 334. 3.06. 3 even, and 3.04. Now the marginal costs are going to be exceptionally tricky this time. Let's see if I've got room here. And that's because the Q's don't, remember before when we were doing marginal costs, that was actually marginal product. We were always dividing by the same denominator. That won't be true here. So let's see what I can do. All right, so for the first one, now remember what we're doing. We're looking at the change in total cost. See, now this is actually working out nicely because if you notice the way this is worked out, the total cost always goes up by 10 in each of these rows. So the numerators will always be 10. It's the denominator that's different. The change in total cost is in the numerator. The change in quantity is in the denominator. Okay, actually, I forgot to add that here. The change, marginal cost, equals the change in total cost over the change in output. And remember, what it's trying to capture is the cost of producing the last unit of that good. So for the changes in Q, we just look at the differences between each row. Like here, for example, we have Actually, you know what? Let me do it like this, just to make it crystal clear. The total cost is 210 minus 200. The quantity changes by 5 minus 0. And that gives us 2. All right. So, yeah, I'm running really low on space here. I think we can just about fit it in there. Okay, so 210 minus 200. Okay, so this is actually 10 over 5, which equals 2. All right, that should do it. Oh, that's good. All right. Yeah, it doesn't really matter how tall this thing is. It's the key is you need to be able to see what you're doing. So for example, for the next one, total cost changed by, it went from 210 to 220, while the output went from 5 to 15. So you've got a ratio of 10 over 10, which is 1. And then for this row, your output went, or your total cost rather went from 220 to 230, when the output went from 15 to 30. So we got 10 over 15, which is only 0.67. Oh boy. Trying to make this as neat as possible. I'm running into my limits here. Let's see. All right, that looks fine. All right, good. All right, now for the next one, we go, the total cost rise from 230 to 240, while the output goes from 30 to 50. So we'll have 10 over 20, which is only a half. Okay. And then here, total cost goes from 240 to 250, while the output jumps up from 50 to 75. So we've got 10 over 25, which is 0.40. So here the marginal cost is falling off pretty quickly, but sooner or later that will stop. So here we go from a total cost of 250 to 260. When the output goes, it only goes up 10 this time. You see what's starting to happen. So we've got 10 over 10, which is 1. And then the total cost goes from 260 to 270. Output only goes up by 5 this time. And so you've got 10 over 5, which is 2. And of course, this is where the law of diminishing returns starts to set in. And that's why this is happening. So we've got here 280 minus 270 over 92 minus 90, which is 10 over 2, which is 5. So you can see once it starts rising, it's going to start rising very, very quickly because the output is increasing very, very slowly, if at all. So now, of course, if you were asked to draw these, which you were not, but the ones that really matter, the important ones that you might ever be asked to draw are realistically average total cost, marginal cost, and average variable cost. You'll see a lot more of those in the coming chapters, by the way. Okay, so hold on. All right, so what we need to illustrate here, and this is, I'm not going to follow this exactly, but this is more or less what you expect to see. Average total cost should look something like this. It falls and then it rises, and you can see that's exactly what happened here. 42, it fell off pretty quickly for a while. It bottomed out at about 3, and you can see it's only just now starting to turn up. But once that starts happening, it'll keep rising forever. Okay, average variable cost has a similar pattern, except, as you recall from the last time, it'll get closer and closer to ATC because the spread between them is AFC, which keeps shrinking as Q increases. And then finally, marginal cost behaves something like this. It typically falls for a while, then it drops and starts to come back, and it'll cut through these two curves at their minimum points. Okay, so that's roughly what those things should look like. All right. Ooh, wow. Okay, so that was a lot of calculations, wasn't it? Yes. So what I will do, of course, is post this on Blackboard so you can look at it later on and make sure you got the same answers. All right. So this chapter was all about costs of production and production itself. In other words, we're trying to understand these different concepts: marginal product, total product, average product, and then we apply the same concepts to costs, because ultimately the costs will help us determine how much output a profit maximizing firm should produce and also what price it should charge based on these cost curves. And in addition, based on what kind of industry we're operating in, depending on what kind of competition we face and that type of thing. So we're going to switch over here to 15, chapter 15, where we introduce the first of our several types of what we call market structure. And market structure basically refers to the economic environment in which a firm operates. So the ones we're going to consider in this class, let's see, let me write a list on here somewhere. Just as a note here, just to tell us where we're going for the next few chapters. A market structure refers to the competitive environment in which a firm operates. The four basic types of market structures are, first of all, we'll start with something called perfect competition, which, as the name suggests, is highly competitive. In fact, it's so competitive that it can't possibly be more competitive. And you'll see why as we start that chapter. It's like imagine the limit to how competitive a market can be. And then we'll have number two, the other extreme, which is monopoly, where there's no competition at all because there's only one firm in the industry. Only one company is able to make this product. Now, there can be a lot of reasons for that. We'll analyze this when we get to that chapter, but the bottom line is if you want this product, you have to go to this company to get it. So there's literally no competition. Then we have sort of an in-between case, which is called monopolistic competition, which is sort of a hybrid between the two. And realistically, I'd have to say the majority of the industries out there fall into this category. But then we also have a case which is closer to monopoly than perfect competition, which is called oligopoly, where what you basically have is a few very large firms that dominate the entire industry. So, for example, aircraft, how many producers are there? There's Boeing, there's Lockheed, there's Airbus in Europe. There aren't that many of them. So that type of industry would tend to be characterized as an oligopoly because they're not monopolies, but they're getting very close to it. So what we're going to do is dedicate one entire chapter to each of these four market structures. And in each case, we're going to spend a lot of time analyzing these same curves that we've just been looking at, along with traditional supply and demand curves. And our goal is to see how they decide what to charge for their product and how much of it to produce in order to maximize their profits. Because we're assuming that in all cases, the number one job of these companies is to maximize their profits. That's always the bottom line. Okay, maximize profits. Now, of course, there are nonprofits out there too, but we're focusing our attention here on competitive companies that are competing for profits. Okay, so this is where we're headed. Now, all of this stuff we've just done in chapter 14 is really the background that we need to properly analyze these market structures. So let's see. Let's go get chapter 15 open here. Now, it just so happens that there are lots of really good videos out there that help us understand these different market structures. And I do have a few here. So first, let me open up chapter 15 for a second. And let's see. Perfect competition. So let me just give you a brief introduction to this. And then I do have one or two nice videos here that I'd like us to look at just to introduce the subject matter. Perfect competition, as you can see, well, it wasn't hard to find some excellent, and I mean excellent, videos about this subject matter. So, but first, let me just dive in here and introduce to you what is unique about perfect competition. Now, remember, this is an extreme case. You may not actually encounter this in the real world. It would be very, let's put it this way, it'd be very difficult to find a situation that is perfectly competitive, but there are cases that are very close. Okay, so in other words, think of this as one extreme, monopoly is the other extreme, and then most businesses operate somewhere in between and have some of each going on. So in a perfectly competitive market, we have a very large number of firms selling the exact same product. It has to be the same product. Otherwise, what we're doing here is not perfect competition. It is something different. Now, because they all have the exact same product, that means that they ultimately will all end up having to charge the same price for this good, because otherwise they'll lose all their business to their competitors. And again, like I said, it's hard to imagine such a situation. Almost every product that you find in the market right now, even for things that are very nearly identical to each other, like Coke and Pepsi, they're very, very similar, as you know, but they're not literally identical to each other. So you might buy a Coke just because of the brand name, or Pepsi just because of the brand name. So that is not perfect competition. But imagine a scenario where you have dozens of companies selling something that they just call cola, and it's exactly the same. The label on the bottle, it just says cola, and there's dozens of these companies selling cola. Well, then you probably end up with something very much like what we're seeing here called perfect competition. And the situation here is that you can't tell them apart from each other. You can't tell one company's cola from another because they're the same thing. So that means that the only way we can compete with each other is on price. There's nothing else. There's no advertising. There's no quantity discounts. It's just price. That's all that consumers are focused on, is what price are you charging. Now, what's interesting is that in one of the videos that you'll see eventually, the goal of the filmmaker here, it was a short video about the real world and how it applies to these concepts. And they found in a small state, well, let's see, small town, I should say, in the Midwest, and they found a product that seemed to fit all of these characteristics. And it turned out to be something which I'd never seen before, which we don't get in the Northeast. It turned out to be a raspberry smoothie. And apparently in this town that he was studying, there are dozens of stores that sell raspberry smoothies, and they're all absolutely identical to each other. They don't have any brand name associated with them. They're just raspberry smoothies. And so if you drive around in this town, every store that sells food has a little sign on it somewhere that mentions the fact that they have raspberry smoothies. So anyone in that town who wants a raspberry smoothie, in principle, can get it from any place they want. And so because of that, they all charge the exact same price, just like you would predict with perfect competition. So I thought that was kind of interesting because it's hard to find examples of this. And also, I didn't even know raspberry smoothies existed. But apparently, and this is somewhere in, I think, Ohio, maybe. It's a small town. For whatever reason, everybody there loves raspberry smoothies. So everybody who has like a grocery store or a restaurant or whatever it is, fast food chain, they're going to offer raspberry smoothies. And so you know that, everybody knows that. They know where to find them. They're everywhere. They're on every corner. There's raspberry smoothies available. And so because of that, the prices are the same everywhere you go. So anyway, we'll see that video later on. But right now, let's just focus on this chapter for a minute. The opposite of perfect competition is monopoly, where there's a single firm selling that good. So unlike the perfectly competitive companies, which have to basically charge the same price to avoid losing all their money, here the monopolist can literally charge whatever he or she wants to sell this product because nobody else has it. Okay, and then we have everything in between. In between, we typically put together these two separate categories, as I've mentioned. We have the monopolistic competition, which is essentially a mixture of monopoly and perfect competition. And then finally, we have oligopoly, which is more like a monopoly. It's almost like, imagine a monopoly, but there's only 2 or 3 companies who offer this product. And they're big, they're really big. So like I said, with the aircraft industry or maybe steel manufacturing, there's just a handful of gigantic companies that do all the manufacturing, and that's it. If you want steel, you have to go to US Steel or maybe Bethlehem Steel. Pretty much that's what you have to choose from. All right. Now with the monopolistically competitive firms, there's a large number of firms, they're selling a similar but not identical product. So in other words, that's the key word right there. Similar, but not identical. So the classic example of this would be fast food. Fast food. Like think about big McDonald's and Wendy's and Burger Kings and all the rest of them. They all have very similar products. But as you know, they're not absolutely identical to each other. So in addition to price, they can compete on brand name. In other words, they can advertise and try to convince you to go to their store instead of somebody else's. And they can make their products a little different, and they can promote those differences. Like with Burger King, they always talk about their flame broiled Whoppers, and McDonald's has the Happy Meals, and they all have something. Wendy's has the baked potatoes. They all have something that tries to distinguish themselves from the competitors. So they're not identical, but they're awfully similar. So in any typical location, like a mall, let's say, you're going to have a lot of these fast food places competing directly with each other. And, if one of them charges a little too much money for their product, it would be easy to walk down and try somebody else. Like, imagine you go into a mall one day and the McDonald's suddenly jacked up their prices 25%. A lot of people are just going to walk further down and go to the Burger King down the hallway, or the Wendy's or the Arby's or whatever. So that's monopolistic competition, because the products are similar enough that there's a lot of competition, but since they're not identical, it is not perfect competition. In fact, the reason why it's called monopolistic is because in principle, McDonald's has a monopoly on the Big Mac. Nobody else is legally allowed to sell it because it is a copyrighted product. But the same thing could be said of Burger King's Whopper. So even though each company has a monopoly on their product, there are so many other similar products available that it doesn't give them a huge amount of market power. Because if I try to charge too much for my Big Mac, the consumer might go and buy a Whopper, for example. If I try to charge too much for my steel as US Steel, my customers don't have a whole lot of other places to go, do they? No. So they probably will just pay the higher price because they need the steel. But yes, you can see the difference here with fast food. It's easy for customers to switch from one chain to the next if the prices change too much. Okay, so these monopolistically competitive firms, They can have slightly different prices because their products are not identical, but they can't be too much different because there's so much competition. Like I said, if McDonald's just suddenly went nuts and decided to raise their prices 25%, I'm sure many of those customers would go someplace else very quickly. They wouldn't stand for it because there's so many other things they could choose from. Anyway, so that's where we're going here. But in this case, we're looking at perfect competition. So here's what we need to know about perfectly competitive firms. First, each firm is a price taker, which means that they all charge the same price. None of them can raise their price, because if they do, they'll lose all their customers to the competition. And I mean all of them. Every single one of them will get up and leave and go somewhere else. With the McDonald's, some of them will leave, but not all of them. That's for sure. If McDonald's raises their price, some of their customers will switch, let's say to Burger King or Arby's, but not every single one of them. Here, though, every one of their customers will go somewhere else. It's like the raspberry smoothie example. If one of those places in that town suddenly increases the price by $1, then everybody in the town knows that there's plenty of other places they can get their raspberry smoothies, and they will just drive down the street and get it from somebody else. And that one store that was foolish enough to raise their prices will lose all of their customers. It's that competitive. It's easy. You could literally walk across the street and get one from the competition at the same original price. So everybody has to charge the same price. Okay, number two, and because every single one of your customers would leave if you tried to raise the price. On the other hand, there's no point in lowering your price because you are presumably small enough that you could sell all of your product at the same price as everyone else. So in other words, in that town that sells raspberry smoothies, there's no sense in lowering your price because you would just lose some of your revenues. The number of customers will not change if you lower your price. In other words, you're not going to make more money this way. So you might as well just charge the same price as everyone else. Okay, so everyone has to charge the same price. Everybody sells the same product. Undifferentiated is a very fancy word for identical. And the industry contains a small number of firms, a large number of firms, like in the case I just mentioned with the raspberry smoothies. Every one of those stores that sells them has other products too, but there's a large number, and for such a small town, there's a huge number of places where you can buy the raspberry smoothies. So you can think of it as a very large number of firms selling the raspberry smoothies. That's why it's so competitive, because everybody knows that it's easy to find them. If you find one store that's charging too much, it's just a simple matter of driving up the street or across the road to get it at the lower price. There's no barriers to entry. Anybody can set up a stand and sell raspberry smoothies. There's nothing to stop you. It's not a copyrighted product. There's no secret about how it's made. It's not like, let's say, Coca-Cola, where the recipes are, of course, copyrighted. You may not set up a company of your own where you make Coca-Cola. It's not legal. It can't be done. Okay. And in fact, you may not know it's possible that nobody knows what the recipes are anyway, except Coca-Cola itself. And even if they did, you're not legally allowed to make Coke. But raspberry smoothies, no problem. There's no copyright on it. There's no secret about what's in it. It's just anybody could start offering them. Even your local bank, what if the bank one day said, we're tired of not having enough customers. Why don't we also offer raspberry smoothies? That could get people in the door. They could do it if they wanted to. Okay. All they need is a little bit of equipment and some raspberries, and they're all set. So it's easy to get into this business, and it's easy to get out if you're not making any money. And then finally, everybody knows what everybody else is doing. All right. The customers know who's charging what, where they're located. Everybody knows what's going on in this industry. All right. Now, one of the oddball consequences of all this, and this is where it really gets strange, and we have seen this before, but the demand curve for an individual perfectly competitive firm, based on all these assumptions, is horizontal. It's a flat line. Now, these are old examples that I was doing with my previous class. But what I wanted you to note here is that, let's say, let me change this from cherries to raspberry smoothies. The demand curve is flat. Look at that. Now, when we were looking at demand curves earlier, we studied this as one of our extreme cases. You might recall this is the case where the elasticity is infinite. The demand curve is flat. Let's say that $10 is the market price for a smoothie. Everybody in this market is charging $10. So therefore, the price that everybody charges is 10, and that also implies that the marginal revenue is also 10. Every unit you sell brings you 10 more dollars, no matter how many you sell. Okay. With a traditional demand curve, of course, it's downward sloping. Okay. So that's what really separates this perfectly competitive firm from all the others. It's the idea that the demand curve is flat. That's a very strange outcome, but that's exactly what we're seeing here. All right, so before we dive more deeply into this, I just wanted to give you some background. Before we watch these videos, let's make sure we watch at least one of them. And because I think they're really well done, and it's well worth our while to watch these. Let's take a look at, now I don't remember, I think the second one is the one with the raspberry smoothie. So let's watch the first one and just get some more background in this area. So first, let me post this for you. And then let's check this out. I think you'll like it. Well, all right. Well, he kind of got ahead of where we are right now. He's introduced some concepts that we haven't started yet, but we will be heading in that direction as soon as the second video is done. But the one I really wanted you to see, I'm pretty sure this is the one. I forgot to label it, where they talk about perfect competition in real life. And I'm pretty confident this is the one where they talked about the raspberry smoothies. So let me show this to you as well. Hold on one second. Um, okay, hold on one second. Let's get, here we go. All right, let's check this out. Grammarly helps make your writing clear and concise, no matter when. But economics doesn't take vacations. If you visit family, the first thing you notice is All right. Now it looks like I misremembered. I thought it was smoothies, it was shakes, whatever. So it's a similar idea. So he's basically demonstrating that for all practical purposes in this town, and I also misremembered the state as well. It's Utah. I forgot. I knew it was some small area where it's the population is not enormous. It was some little town in Utah on the border with Idaho, where for some reason the raspberry shakes are so popular that every single store has them. And while you couldn't expect the prices to be literally identical to each other, because like he said, there's a size difference, which is of course going to affect the prices. This is as close as we're going to get to a truly perfectly competitive market in the real world. So I thought that was kind of interesting. And it shows that there are some products for which perfect competition is not that far off as an explanation for the size and the quality and everything being the same and the same price. So I thought that was kind of interesting that you would like that very much. Now, let's get back to the actual slides. The first video introduced some topics that we haven't quite covered yet. What they were addressing is what I have right here on the next slide, is that while the perfectly competitive firm has this flat demand curve, in this example at $10, where did it come from? Well, here's where we have to make a distinction between the individual firm and the entire market for that product. So imagine that, again, we're looking at these raspberry shakes. Okay. So what's going to happen is that if you look at them as a whole, the market for raspberry shakes, and now I have to fix shakes. I think the only difference is that the shakes have milk or ice cream in them. The smoothies are just pure raspberry juice, as far as I know. I'm not really an expert in smoothies and shakes. Does anyone out there know what's the real difference? No. Okay. Well, that's all right. I don't either. But I think the difference is whether it contains ice cream or not. A normal smoothie, you're just basically throwing fruits into the blender with maybe some sugar, and then you're basically drinking the juice of the fruit, rather than with the shakes here, it's actually ice cream and the flavor of the raspberries. But anyway, so as I started to say, so what you have to do is visualize the market for these shakes means all companies that are producing it. And so for the entire industry, the entire raspberry shake industry, there are other products that people could buy. In other words, let's say that they go out and find some other drinks that they prefer. So for the industry as a whole, the demand curve is still downward sloping. Okay, so in other words, there's a supply curve, a traditional supply curve. There's a traditional demand curve, which is downward sloping, but this is for the entire market or industry, because we can think of this industry as having competition from other drinks that people might like to buy. Okay, like maybe chocolate shakes or smoothies, as I mentioned earlier, or something else that is sort of like a frozen type drink that people might enjoy. So the shakes themselves have competition from other types of drinks. So remember what it means to have a downward sloping demand curve. In order to sell more of this product, we have to lower the price. That's why it's downward sloping. But again, this is with respect to every other product in the market that is competing with raspberry shakes. There's also the traditional supply curve. So here, initially, we were assuming that where the supply and demand curves in the market came together, that generated a price of $10. And now the individual firm will charge $10 for their shakes. Now, in this diagram, what I've also shown is what happens if more competition comes along. If more, let's say you're in Utah, like I said, imagine that in addition to fast food places, that suddenly other kinds of companies started offering raspberry shakes as well. So the supply curve shifts to the right for the entire market, and the price drops, let's say, to $8. And now every individual firm that sells these shakes has to charge $8. They have to, because as he said in the video, if you tried to raise the price, look how many other options you have. You could just drive anywhere in that town and get a raspberry shake for a lower price. So you cannot raise your price. You have to charge the same as everyone else. But there's no point in lowering the price because you'll still get the same number of customers anyway, basically. So the competition, so for the firm, we have a flat demand curve. For the entire industry, though, we have our traditional demand curve, which is downward sloping. And again, where it intersects with the supply curve, that is the equilibrium price that every one of these firms is charging. And then because the curve is flat, you notice all along this curve, the demand equals the price, which in turn equals the marginal revenue, which is not normally the case. You see this downward demand curve. Here, this is not true. D does not equal P, which is not equal MR. This is only true on a flat demand curve. Okay? So these are some of the interesting, unique consequences of perfect competition. Now, here we're going to formally define marginal revenue to represent the change in total revenue that results from selling one more unit of the product. And I want you to see how it is directly related to the marginal cost function that we saw earlier up here on the top, which is the change in total cost over the change in quantity. They're very similar ideas, the difference being that one is cost and the other is revenue. So anytime you see the word marginal in economics, it means you're looking at the change in one variable with respect to a change in the other variable. And this is no different. Okay, so two of the more important marginal concepts that we'll run into are marginal cost and marginal revenue. All right, so up here, a quick reminder, this is the change in total cost over the change in quantity. Okay, now this next slide is one of the most important slides you'll ever see in your life in economics, because it turns out that no matter what kind of market structure or market industry you're working in, the way to figure out the profit maximizing output is with the following relationship. You want to produce where MR equals MC. All right, MR equals MC. If you were to write up a list of the most important, let's say 5 or 10 concepts in economics, this would have to go to the top of that list, because all of our decision making is going to come down to this principle that you must, or you ideally should be selling your product at a point where the marginal revenue equals the marginal cost. What this means in English, let's see, in English, this means that the additional, hold on, let me see if I can squeeze this in here. We want that right there. We want it to be very obvious that that's important. The additional revenue, and we'll go over this, not maybe today, but next time we'll explain why this is happening, because this is so important and we don't want to rush through it. The additional, let's say, what this means is that the additional revenue obtained from selling one more unit of the good equals the additional cost of producing it. So in other words, imagine if it cost you $8 to make a raspberry shake, then you would want to sell it for $8. Now, it doesn't sound right, does it? It sounds like you might think, well, shouldn't we charge a price where marginal revenue is higher than marginal cost? But it turns out that that's not actually the best way to go. And again, this is something that needs a lot of explanation. And that's exactly what we're going to do, just not today. But just keep in mind that no matter what market structure we're looking at, this is always the same. Marginal revenue equals marginal cost is where you want to produce your product and what you want to charge for it. to make sure that you maximize your profits. All right. So, okay. So I think we got plenty done today. And so we'll pick this up again. We'll take a step back and really dive deeply into these concepts. And I have maybe 1 or 2 more videos that we should watch anyway. So right now, why don't we stop it right here? I will post the solutions to the chapter 14 problem sets so you can double check them. But in the meantime, just make sure you understand what we did today. And then I'll see you all on Friday. Oh, wait a minute. Is the school open on Friday? I think it is. They're not closed for Good Friday? I'm pretty confident that they're open. No, sorry, they're not. No. I'm up to my eyeballs in tests. Don't worry. Soon enough, they'll be ready, but not just yet. But anyway, I don't think that the school is closed on Friday. So yeah, I'll tell you what, we'll show up on Friday unless I send you an email that says otherwise. One of my other schools is closed on Friday, but I'm pretty confident Manhattanville is open. So we'll just plan a meeting on Friday then. Okay. All right. So I'll see you Friday then.
Thank you.
Okay. Bye. See you next time.